Thank you very much and welcome once again in our class. And this time round, we are going to consider a subtopic, the turning point of a curve. And that equation is y equals to x squared plus 3. Y equals to x squared plus 3. Now, we are going to get the derivative or the gradient function of this equation. The gradient function of this equation is dy dx equals to 2x. That is the gradient function, and this one tells us will give us the gradient of x, the gradient of this curve at different points. Just to fill this table using this gradient function. The table we have has values of x running from -3, -2, -1, 0, 1, 2. In other words, when the value of x equals to -3, what will be the gradient? When the value of x equals to -2, what will be the gradient? We only have to just substitute this value here for the first box, 2 multiplied by -3. So from the first box, you realize that the gradient is going to be -6. Then the second box, 2 times -2, because the value of x is -2, then the value is going to be -4. Then we have the other one, 2 times -1. This one is going to be -2. Then we are going to have 2 times 0. The gradient here will be equal to 0. Then we have 2 and 1. Then the gradient will be positive 2. Then we have the final one, which is 2 and 2. So this one is 4. So the gradient is positive 4. So you see, as you move along this curve, given by the function y equals to x squared plus 3, the gradient along this curve changes. The gradient along this curve changes, and you realize that it's changing from negative to positive. For example, the nature of the gradient when the point is -3, the nature is negative, and the nature of that gradient when the point is -2, it's also negative. Then the nature here is negative. The nature here cannot be described as 0, because we don't have a positive 0, negative 0. Then the nature here is positive, and the nature here is positive. So our gradient is moving from negative then to positive. And now there is a point here which is of our interest. When this curve is turning from the negative to the positive. This point where the curve is turning from negative to positive is what you're calling a turning point. So this part where we have the gradient equals to 0 is what is of interest to us, and is what we are calling a turning point. So the turning point for this curve, it's a point 0, and the gradient at that very particular point where the turning point of a curve is, it is always 0. The turning point of any curve, the gradient at the turning point is always 0. The graph of the function y equals to x squared plus 3 is as shown on this diagram. Now you realize that on this side, the dy dx, or the gradient function, is negative, and when we come on this side, the dy dx, or the gradient function, is positive. This one, as you go down, is negative, and this one, as you go up, is positive. But there's a particular point which is going to be our interest, this point where the gradient is not rising or not falling, this point where the gradient is equal to 0. This is what you're calling the turning point of this curve. It's what you're calling the turning point of this curve. It's called minimum turning point. A minimum turning point. I have another equation on the board, and the equation is y equals to negative x squared plus 3. So we want to get the gradient function of this and get the gradient at different points. We want to get the gradient function of the equation and get the gradient at different points. So the gradient function is dy dx equals to negative 2x. The gradient function is dy over dx equals to negative 2x. Now this one, if we want to get now the gradient at this point, it is negative 2 times negative 3. So this one will be positive 6. Then the one that follow at point 2, it will be negative 2 times negative 2, it will be positive 4. Then again, negative 2 times negative 1, when you multiply it, it's going to be negative 2, positive 2 here. Then at 0, when you multiply with 0, negative 2 is 0.0, it's going to be 0 there again. And again, we have negative 2 times negative 1 is going to be negative 2 there. Then we have negative 2 times 2 there. It's going to be negative 4. So the nature of the gradient at this point is positive. The nature of the gradient at point negative 2 is positive. And the nature of the gradient at negative 1 is positive. At this point is 0. And at this point it is negative. And at this point is negative. So we realize again that this gradient is coming from positive, positive. Then when it gets here, this 0 represents our turning point. Okay, this is the graph of that very point we drew earlier. We will see that this side is positive, the positive, then it turns to negative, negative, negative. This is where our gradient was 0. Our gradient function was 0. So this one is where the turning point is. This is where we have our turning point. That's where we have our turning point. And this turning point, we are calling it maximum. The gradient at the turning point of any graph is always 0. The gradient of any turning point, like what you are having here, is always 0. That's the most important point to note. The gradient of any turning point is always 0. And also another very important point to note is when the curve is maximum point, the value of y is greatest at this point. And the gradient of the curve is always 0 at that particular point. Also, when the point of a curve is minimum, the value of y is the least point at that particular point, and the gradient at that particular point is 0. Those are 2 points you have to note carefully. So, a stationary point is the point on the curve which the gradient of the curve is 0. A stationary point is a point on the curve at which the gradient of the curve is 0. For what we have seen here, the gradient is 0. And a turning point. So there are 2 things here. In the turning point, we have the stationary point and the turning point. The turning point of a curve at which the sign of the gradient of the curve changes. The turning point is the point of the curve at which the sign of the gradient changes. You see, this is positive going up and it's negative. So this is the turning point because the gradient is going to change at this point. This one is positive, positive, and it's going to change at this particular point. Hope you have taken that point well, because it's a very important point. So, we are able, when given an equation, we are able to give the nature of that very particular point. We are able to give the nature of that particular point, and now we are going to examine the nature of the turning points for given equations. Example 1. Identify the turning point and the nature of the turning point of this equation, which is y equal to a third x cubed minus 2x squared plus 3x. So what you got to do here, solution, we find the credit function, which is dy over dx. So this one is going to be, this multiplied by this, you get x, because 3 times a third is x. So it's x squared minus 4x plus 3. So our gradient function for this function is x squared minus 4x plus 3. We know that at the stationary point, the gradient equals to 0. That's what we said. At the turning point, the gradient equals to 0. So we have our gradient function, and this one we are going to equate to 0 because that is where the gradient goes to 0, and that's our turning point. So this one is going to be x squared minus 4x plus 3 equals to 0. So this is a quadratic equation we have to solve, and we are going to solve it by use of completing square method. So this one is x squared minus 4x equals to negative 3. Then we are going to have x squared minus 4x plus 4 over 2 squared equals to negative 3 plus 4 over 2 squared. Then this one you are going to have x minus 2 squared equals to negative 3 plus 4. This one is going to be x squared, x minus 2 squared equals to 1. So when we take the root of every side, we are going to have x minus 2 equals to plus negative 1. Plus negative 1. So we are going to have x equals to negative 1 positive 1 plus 2. So that x equals to 3 or 1. 3 or 1. So there are two turning points here. The first one is x equals to 3, and the other one is x equals to 1. There are two turning points. The first one x equals to 3, and the second one x equals to 1. Then we are going to move on again. We are going to move again now to examine the nature of these turning points to see whether these points are maximum or minimum. We are going to examine the nature of these turning points to see whether they are maximum or okay. On the number line, you realize that 3 with 3 means the number on the left is 2 and the number on the right is 4. So this one is going to be 4 and this one is going to be 2 there. So we are going to look at the gradient function of this one here, so that we have x squared minus 4x plus 3. So this one here, when you substitute, it's going to be 2 squared minus 4, 2 plus 3. So that you have 4 minus 8 plus 3. So it's negative 1 there. Then again, we look at it when it's the middle. The middle one will always be 0 because it's the point we have. It's a turning point, it's always 0. And this one here is going to be 4 squared minus 4 again plus 3. So this one is 16 minus 16 equals 3. So this one is positive 3. This one is positive 3. So the nature, this one is negative. This one is, of course, constant. And this one is positive. So the nature here is going to be going down, then constant, then rising up. See, it's going down, constant, then rising up. Look at this. This one is what? A minimum turning point. A minimum turning point. So 1 is a maximum turning point and 3 is a minimum turning point. You can see we can be able to sketch these points, and we are well able placed now to tell the nature of these 2 points. The nature of this one, the first point, is is maximum, and the nature of 3 as a turning point is the minimum point on that curve. The assignment today, we have one question. Find the stationary point on the curve and state the nature of the turning point of y equals to x raised to 3 plus x raised to 2 minus x. I repeat again. Find the stationary point on the curve and state the nature of the turning point of y equals to x raised to 3 plus x raised to 2 minus x. Do the assignment, then take the photo with the phone, and it should be a clear photo, then send to my WhatsApp account on 0724 700 686, and I will be able to mark your work and return you return to you with the comments which are supposed to make you grasp this area, and also be able to add you more questions if possible, so that you can be able to grasp this area. Thank you very much. Let's meet next time.